Assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
Okay, for this problem, you're given a situation where there is a block that is attached to a spring and it has a known mass of 5 kilograms, and then it gets hit with a bullet that is embedded into the spring and causes it to undergo a simple harmonic motion. So our known values here are that we have the mass of the block is 5.00 kilograms. We know that the spring constant is 6,000 newtons per meter. We also know that the mass of the bullet is 9.5 grams, which is equivalent to 0.0095 kilograms. And we know that the velocity of the bullet is 630 meters per second. So this is the information that we have, that we're given. And we're trying to figure out what is the velocity of the block after the collision. And we're also trying to figure out what is the resulting amplitude of that motion going to be after the fact. So first we have to think about the law of conservation of momentum, which states that the momentum before collision is going to be equal to the momentum after the collision. And so we get the equation, the mass of our bullet times the velocity of that bullet is going to end up being equal to the combined masses of both the block and the bullet times the final velocity, the velocity we were searching for. So when we plug in our known values, we have 0.0095 times 630 equals our masses, so 5.4 kilograms plus the mass of the bullet, the 0.0095 kilograms, times our V final. And we get a resulting answer when we solve for V, that V equals 1.1 meters per second. So that is going to be the velocity of our block. So after the bullet hits, the block will move with that particular speed, that velocity. The second part of the question is asking us about the amplitude. And so we're going to have to take into the similar, but the idea of the conservation of energy, because however much energy was in the bullet, once it hit that the block and the bullet are going to maintain that same amount of energy. So we're going to be using the equation 1/2 mass of the block plus the mass of the bullet times the velocity squared is going to equal 1/2 our spring constant times our amplitude squared. So again, plugging in our values, we have 1/2 5.4 plus 0.0095 times our velocity, which we just found, which is 1.1 squared, is going to equal 1/2 our spring constant, which is 6,000, times our amplitude squared. So we end up with 3.27 equals 3,000 xm squared. And if we continue to solve for that, so we would divide the 3.27, our xm is going to equal 3.27 divided by 3,000, and then we're going to be taking the square root of that value, which gives us an answer of 0.033 meters, or 3.3 centimeters. So after the bullet embeds in the block, the amplitude of the simple harmonic motion will be 3.3 centimeters.